Make a real quick distribution. We're going to start with 0, 1, 2, 3, 4, 5, 6, 7. We'll go 8. Okay? Now I'm just going to come around. I'm going to ask you how many pets you got. You're going to give me one of these numbers, right? So, Chance, what do you got? Don't count your cows and chickens and stuff. 2? I already saw that working in his head. Like, oh man. What do you got? 3? 1? 0? That's good. 3? 3? 3? Good. 0. Nice. 3? 1? 6? Dang, girl. 1? 6? Okay, you're not alone. Elisa? 1? 1? Right here. Ariel? 7? Julius? What do you got? Don't count your brothers and sisters. No, I'm just messing. What do you got, bro?
You can count them as a animal.
I know sometimes you feel like in a bestia. What do you got?
I like 11.
Dang. Okay. 9, 10. That's not bad, but that's a lot. Okay.
Low-key, there is a guy on campus with 10 dogs.
Nah, that's too much.
Oh, is that what's it?
Dylan Lopez has 10 dogs.
He has 11, he got a new one.
Ah, oh my
I
god.
have 9.
That's so
How do you take
gross.
care of them?
Wow.
But mine are all the same.
Okay.
I didn't count all of them.
What's that? Well, we're just getting an idea here. What do you got? 2? Man, 9. Hey, hold on. There we go. I can get your 11 in there. 2? 2? Go ahead. 5. 4. 1. 10? Yorbit, ¿cuántas mascotas tiene? Get your headphones out y despierte. ¿Cuántas mascotas tienes? 0. Chamaco este. 3? Okay, and 0. And I've got 2. I have a golden lab and I got a min pin. So I got like a little dog and I got a big old dog. And the little dog always trying to get the big dog. Thinks he's awesome. So there you go. That's the distribution for this class of pets. That's what distribution looks like. Okay. Sometimes you'll see them, and what they'll do is they'll put a curve on this. So in this case, let's see if this will. Well, it's still what the. Okay, whatever. Okay, in this case, they'll kind of do that, and they'll just show you the curve, and they'll say that's the distribution or the shape the distribution takes on. Okay, so they just kind of mimic it, but what you're looking at is definitely the distribution. Just that simple. It's all of the values that it takes on. And what is this population right here? What's the name of this population? How many pets in
A household.
not a household, in
One class?
in this class, this specific class here, okay? Because of course this would look totally different if we had another class or another class or another class, right? So right now the population is you guys, and that's what our distribution would look like. Make sense? Okay. Now this, we'll talk about what the shape of this one looks like in a little bit, because we'll talk about all that. But that's what a distribution looks like. Bar and pie charts. They show relative frequencies. Don't even worry about those. I'll try to delete that slide. Here's something important to know about this thing called good charts. Make sure that you got a title on there. Why? We want to know what you're talking about. Okay? Make sure that you label the axes. Okay? What's on the X? What's on the Y? Make sure that you have consistent scaling. Don't be like 0, 1, 50, 51, 52. Like, what the heck happened? This thing just jumped like 50 some points. Okay? So kind of like this. Now let's say you did have data like that, or that you did have information where it went 1, 2, 3, 4, 5, 20, 21, 22, 23. That's a big jump, isn't it? Okay. It's actually, they do this. So if you're going to go 1, 2, 3, 4, 5, you're going to show that there's a break in the data. Just put 2 lines through it like that. And then you're going to go 20, 21, 22. I haven't seen the squiggly. What's it look like?
Well, it's like when you go up. It's like right at the beginning, like if you have like 5, or like you start, you just, instead of starting at like 0, you go to like 50.
So if you start at 50, then you would do what?
It was long.
Like this?
And I can't see it.
Oh, sorry. My bad. Big boy.
No, it was like it'd be like in the line, it'd be like a squiggle and then you'd go up. But,
Okay. I have to take a look at that. I haven't seen that. But I'm not saying it's not right either. Just haven't seen it. Okay. So you make sure if you have a break, use those kind of double slashes. Show everybody that this data is not consistent all the way through. Okay. Because sometimes that can be misleading. All right. Quick graphs. Quick graphs. Sometimes you just want to get a distribution, see what the distribution looks like. We already did one of them, which was called a dot plot. Called a dot plot. I think everyone's already seen a stem plot, right? We used to call it a stem and leaf. You guys remember that?
Oh yeah.
Okay.
That was
We just get lazier as we get older, so we call them stem plots. Okay, box and whiskers. You guys heard of box and whiskers? No? Okay. Well, we'll talk about those. We just call them box plots. We start dropping all the little cute stuff. Okay. So stem plot, it really is exactly that. You're gonna have a stem, which probably be like your your units, 10s, 20s, 30s, and then you start attaching the leaves, which means this is 1, 1, 1, 2. This would be 11 because there's your stem and your leaf. That would be considered 13, 15, and so forth, so forth. Okay. What's nice about the dot plot over the stem plot is the dot plot's faster. Okay. You don't have to worry about organizing and where it goes. You just kind of do a dot. You guys saw the graph I made, right? With all the dots. Guess what that is? That's a dot plot. Okay. Now, stem plot's a little bit tougher to look at because it kind of is sideways like that. But the benefit of it is, one, you get to see the data, and second is if you kind of look at it on its side, you can still see the shape of the distribution. So that's a nice plus on that one. Okay. And I'll show you some examples of how that works in a little bit. Can I move on? Right on. Awesome effects. You see that? It took me like 2 hours to do that. Okay, so dot plots. I don't have to show you that. I already did. Here's stem plots. So we talked about the stem and the leaf part. One thing that's important to know as well, stem plots don't work for large data sets. Okay? They just don't work. Can you imagine if you have 100 numbers from 1 to 20? Like 2 long columns, right? Like, it's ridiculous. It's like, that don't help me at all. Okay, and that's even worse when you're looking at pie charts, okay? Pie charts are horrible when you got like a bajillion categories. It's like 50 lines all the way across there. You're trying to slice up that pie. I don't think so. There's my awesome effects again. Don't ask me how I did that. Okay, but here's an example of a stem plot, Julian. Okay, you got your stems right here, and then you've got your values that are attached to each one of these. And like I said earlier, it's nice because if you kind of look at it, you guys can see on the side, you can still see the distribution of that. So it kind of does this bit here, and there's the shape on its side. So you can talk about the distribution and it being skewed or having outliers in it. So really nice to look at that way. Okay. Now in this case, you guys notice something interesting? There's a 4, 4, 5, 5, 6, 6. You guys ever seen a stem plot like that?
yeah.
No. It's 2 sets of each. This is called the broken stem. Okay? And the reason why they call it a broken stem is because sometimes you want to take a look at values. Like in this specific one, it would be numbers from 0 to 4. And over on this one, you'd have numbers from from 5 all the way up to 9. So they kind of break it up. Okay? So if you do have big category or large data sets, then you might want to break them up. Just because you have 2 sevens doesn't mean you can't have 3 of them, or 4 of them, or 5 of them. Okay? So depending. Questions on a broken stem? Seems simple enough? Yeah? Awesome. Moving on. This is really cool too, which is a back-to-back. If you ever want to compare 2 distributions, for example, the American League versus the National League, and you want to see how they were doing as far as wins are concerned, here's a back-to-back stem plot. Okay? You still use the same stem, but the leaves are for American. Uh-huh. My bad. There you go. So you have your leaves for the American. You can see that distribution, and you can look at the National League and its distribution. So really nice way to compare two different things. You know, sometimes you want to do boys versus girls or whatever. Okay, back to back, really nice. Okay? You're all about that, aren't you?
Oh, there actually is a 6 by 6.
Is there? Oh, right here?
No.
No.
Right there.
Oh, crap. That's all good. I'm not scared. I'm going to change that slide right after class. Watch. Delete. All right, so now. That's stupid. I'm going to shut up. Describing distribution. So, when you do get a distribution, once you got your numbers, you put them in that little family plot, or you put them in a dot plot, you're going to want to be able to describe that thing, okay? So there's 4 things that you want to make sure you talk about. And they are, for starters, the center, okay? Where's the middle of this distribution, okay? And I think you guys have already talked about some measures of center before, back in elementary school, right? One was the median, and the other one was the mean, okay? Mode is more of a what happens the most type thing, okay? But definitely median and the mean. Okay, those are two measures of center. But when you're doing this, guys, when you're just talking about it, you don't have to be exact. Okay, you can be vague. It looks like the middle is somewhere around 50. Okay, it looks like it's somewhere around 25. Okay, it could be somewhere from 15 to 20. Okay, so because you're just talking about it, right? I'm trying to explain to you what this distribution looks like. So talk about the center. The other thing you want to talk about are there any unique features here? Okay, is the shape all funky? Is it got 2 humps? Is it shifted? Is there a cluster of data and then there's a few little bit more over on the side somewhere? That's your unique features. And usually that's when you want to talk about outliers, okay? Those are numbers that just kind of don't stick with the click kind of thing. Okay, you've got the big stack of numbers over here and there's like one over there by itself. That definitely could be considered an outlier. You might want to talk about that. You also want to talk about the shape. And I'll give you some options for talking about shapes in a little bit. So you want to talk about shape. And you want to talk about the spread. Okay, so think about the range when we talk about spread. There's a couple different measurements for spread. We'll talk about those. But it's really just, where does the data lie? Where does it go from where to where? So, if you want to remember how to describe a distribution, just think that all you got to do is cuss. C-U-S-S. So if you think, describe a distribution, I can cuss. That should help you hopefully remember. I'm talking about center, unique features, shape, and spread. C-U-S-S. That always helped me because I thought it was funny. They want me to cuss. Questions on describing distributions? May I move on? Hey. Okay, cool. Oh man, can't get enough of those effects. Okay, so center. Center is the average, or it's the middle of the value of a histogram, depending on what you have there. So where is it? What is it near to? Is what you want to be asking yourself. Is it one number, or is it 2 numbers that are in the middle? Okay. So center again, very vague. Some unique features. Okay. Take a look at the overall pattern. In this case, this would have 2 humps, right? If I kind of try to put that little line over it, that distribution type thing. Okay, or I can even say, look, like there's some outliers. There's all this data over here, and I got a few of them over here just sitting by themselves. Are there any deviations from the norm? Okay, so those are the unique features you want to be talking about. And of course, outliers. Describing shape. There's a couple different shapes, so take note of these. Make yourself a little sketch on the side somewhere and label it. Here's one. It's called uniform, and it looks like. Oh, I just give you names. Oh man, I'm just awesome. See all that effects? I'm so good. Okay, cool. Here's what uniform looks like, guys. That was that first option. Okay, it's just flat. Notice that no matter where I go, whether it's 1 through 10, I've got the same value of 13,489. So that creates a uniform distribution. Okay, nice and flat. Anybody ever seen a uniform distribution? Yeah, you just probably didn't think about it. Okay, if you want to think about rolling one die, how many different numbers can you roll? That's it, right? So you would have one option for 1, one option for 2, one option for 3, one option for 4, one option for 5, one for 6, and that's it. So it would be a uniform distribution. Make sense? The other one you can have is this thing called a bell shape. Okay, and it looks like a bell. That's why it's called a bell shape. Looking like a bell. And if you look at the stem plot, you can still see the bell shape in here. You guys see that? Bye. So that's why I like the stem plots, but they just take a little bit longer to work with. Okay, skew. Notice how this was bell. We actually call bell, we also call it a normal distribution. So you might want to put that on the side somewhere. We call this a normal distribution. But then you have things where they don't look like this, right? You got one side longer than the other side, kind of like with ours. Okay, Julian, pick your head up, take a beating off. Thank you. Okay, take a look at this distribution. That looks like what we had at the beginning, right? Okay, this is called a skew distribution. Now this is a specific type of skew. Where's the tail at, people, on this one? Where's that tail then? It's on the right side, isn't it? Okay, so this would be considered a right skew. Okay, it would be a right skew. If your distribution had a tail on the left side, then what do you call that? That would be considered a left skew. What the heck? What? Guys, what if the tail was on both ends?
Double skew.
No, it's a normal distribution, right? If the tails look the same on both sides, it's symmetric. And if it's symmetric, then we just call that a normal distribution, or that bell-shaped curve, okay? The only ones that have names are the ones that got the two tails. If it's the same on, oh, that's horrible. that wasn't normal at all. But you get the idea. If the tails are the same on both sides, and it's symmetric, then you would call that a normal distribution or a bell-shaped curve. Okay, here you can see that skew as well. This one's called bimodal. And bimodal, because it happens the most, bi meaning two, that means it happens the most 2 times. So you've got this double hump thing going on. You. I wish I could let you sleep.
You can.
I can, but I won't. Okay, so, and again, you can see that when you take a look at the stem and leaf plot. And there you go. Questions on those shapes? Any one of them?
You missed, it starts with the S name. On the slide there was like S in something. I didn't get the rest of the name down. When I have all the list of the names.
Symmetric?
I guess.
What does symmetry mean?
Oh, okay, it's the bell one.
Well, not just the bell. What about this one? Isn't that symmetric?
Yeah.
Is that symmetric?
Yeah.
Is that symmetric? So it's just kind of like is that symmetric? That could be. So it's just kind of like a label you can attach to something. Okay. Spread. I think we have time for this one, and then I think we'll be done here. Spread. It's what is the range of the data. Okay. And I think the one that you guys know the most right now for measurement of spread is range. Oh, the numbers go from 2 to 12. I don't know. Okay, and you guys usually figure out that number by taking the smallest number and subtracting that from the biggest number, right? That was the easy way of doing it. So that's that spread. Histograms are flexible. What happened? Did I go too fast? Don't worry about too much. Here's something interesting to know about histograms. I think everybody's seen them before, right? You got, for example, you gotta have a bar and it goes, oh, this goes from 0 to 10, right? You guys seen that? And then you'll say, oh, so then that means the next bar would go from 10 to 20 type thing. So what type of numbers would fall into this first bar here? What, can I have a 0 in here? Can I have a 1, 2, 3, 4, 5, 6, 7, 8, 9, and no, that's it. That's it. Okay? So that's the deal with histograms, is even though I say from 0 to 10, I'm actually going 0 to 9, and the 10 would actually jump on this block. So this would go 10 all the way up to what number? 19. And 20 would actually go into the next bar. Okay? So make sure you guys are careful with that. And that's what this means. When we're talking about those ranges, we include the bottom one, that's why it's equal to, but it does not include the top one. Okay, so it just goes from the bottom one to one less than the top one. Okay? I mean, we could put like 19 or 9.99999 in here, but once we hit that 10, we got to jump over to the other bar. Yeah! Discard. Okay, we're good here. We're done with that. For your favorite part. Oh, shucks. Come on, Steve. Already? This already second day class.
I don't know, like I do for like my other classes. I'm honestly so
You
bad.
should have them already. Well, you don't need it. Hold on. They're gonna ask for it too.
I'm so glad I'm gonna take this class. Yeah, I didn't learn any of this last year. My teacher didn't even talk to us. She's so rude. Girl? Yeah. He failed everything.
Okay. So you just got a worksheet. It's just a bunch of data sets. Tonight you're going to use it to draw all of the distributions for each one. And then you're going to talk about the distribution. So you're going to say, so you're going to create the graph or the dot plot for it. And then you're going to talk about center, unique features, shape, and spread. Okay, you got, I think, 10 problems on here? 10 problems. Okay? When you turn that homework in, so make sure that you do this on a separate sheet of paper. Because the data sets, we're going to use them over and over for a little bit, okay? So tonight, all you need to do, draw the dot plot, and talk about the distribution. That's CUS. Shape, unique features, shape, and spread. Questions on that? Keep it simple tonight? Okay, you got 10 of those to do. You can start right now. Whatever you don't get done, homework!
Can we do it on a separate piece of paper?
Please do, because you're going to use this again tomorrow for different homework. So please do it on a separate sheet of paper.